This little component is not a transistor. It looks simple, just three legs, and you might have seen them somewhere and just ignored it. But here is the plot twist. It's programmable. Now, when I say programmable, I don't mean writing code or uploading firmware like you would do for a microcontroller. No IDE, no flashing. This isn't digital. This is a precision control device hidden in a plain sight. You will often find them inside SMP power supply, quietly monitoring voltage, correcting errors, even saving devices from overvoltage disaster. So how then is the chip programmed? Here, programming means using external resistors to command how this chip behaves. It's like configuring a smart sensor, only this one works with a pure voltage and analog logic. So get yourself ready, because before the end of this video, you will learn the basics of how it works and how to program it to work for you, how you want it. This is just a simplified schematic of the TL431, and you can find that it does have a symbol of a Zener diode with a third pin known as the reference pin. So which you should be curious enough about the how and why, and which you would make a research for its datasheet to see its functional block diagram to understand better. It consists of three components that makes up this IC: the voltage reference of 2.5 volts, the monitor, the op-amp, the decision maker, and the transistor known as the gatekeeper. Normally, a voltage at the reference pin is less than the voltage reference. The output of the op-amp stays low, thus the transistor is off. It's like the gatekeeper. He either sinks current or stays off depending on the comparison result. So the output is pulled up high to the power supply voltage by a resistor that is normally connected to the cathode of the IC. But as soon as the reference voltage is greater than the voltage reference, the output of the op-amp turns on, and so does the transistor activate, which pulls its output low to around 2 volts. So the IC acts like a comparator, comparing two voltage at its input, the reference voltage and the voltage reference. To understand how op-amps and comparator works, check this video, link in the description box. I have made a video on that. This is a simplified circuit of the TL431, which is programmed to work as a constant 2.5 volt Zener diode that no matter its varying or change in voltage at the input, the output stays the same as it was programmed to. We can form any constant voltage we need by forming a voltage divider at the reference pin and get a constant 5 volt with two identical 10k resistors. With this idea, we can make it an adjustable voltage reference using a potentiometer to replace one of these two resistors while the input stays the same. The outputs can be adjusted to the desired voltage at which we want it to operate at. In order to program this to work for you at the voltage you want it to operate at, you can use this formula given. Using this will help you to find what your constant output voltage will be. So to take this project further, we can actually design a simple undervoltage cutoff circuit that will cut off its output voltage when a certain drain voltage is met. How this works is that when the voltage of a battery drops down to 7 volts, it automatically cuts off the circuit, preventing any other further current from supplying to our load and saving the battery from draining completely. You could use this formula in order to set your battery undervoltage cutoff voltage. And that's it, the circuit works. This is an auto cutoff circuit designed with TL431, which monitors the battery level charging system. So once a certain voltage is met for a battery, it cuts off the circuit, preventing it from overcharging. So we have 5 volt as our input supply, and this lithium battery is just 1 volt. So let's get it into charging and see how the TL431 monitors its charging level. So currently it's charging. When it gets to 4 volt, it should automatically cut off at the process with the LED illuminating telling us fully charged. So for the sake of time, I shortened the video, get the part it got fully charged after leaving it to charge for a while. So I took out the battery to confirm that, and you can see it's fully charged, 4 volt. How this circuit works: if the battery is below 4 volt and we apply 5 volt at the input, the battery starts charging and the current will flow through it. Also, the supply voltage will drop. As long as the voltage is below 4 volts, the reference diode will be open. So the P-channel MOSFET is off by the pull-up resistor at its gate. So at this point, the only path current flows is to the battery. But once we get to 4 volts, the reference diode conducts and makes the connection between the gate of the MOSFET and ground. Thus, the MOSFET becomes active, allowing current to flow through the diodes, which will act as a new load. So now we are wasting power instead of charging the battery, and that's how the charging process is stopped, with the LED indicating fully charged. Okay, that's all for this video. If you found this helpful, remember to like, leave a comment, and also share this with your friends.